So we did this warm-up. We found these segments from vertex to midpoint, and that point is the point of concurrency. Now, on our notes for today, I want you to underline and circle what I do. All right, so median of a triangle. On our warm-up, those lines we were drawing are called medians because it goes from a vertex to a midpoint. Underline, vertex, midpoint. So from now on, when I say median, you're going to know that connects a vertex corner to a midpoint on the segment across. Okay. Now, if I make 3 medians, that creates a, box this, point of concurrency. And we just explained point of concurrency where 3 lines cross. Okay. And it's called the centroid. Okay. So it kind of sounds like center and rhymes with asteroid or android or whatever. Okay. But centroid is when you make 3 medians. That's the new point. That's one of the centers. So this unit, we're talking about centers of a triangle. There's more than one. There's more than one center of a triangle. And I'm going to show you 4 different ways to find 4 different centers. And then we have a little lesson on mid-segments. But here's the deal. This unit, okay, not everyone's a fan of it. Understandable. So we're trying to get it done in a week, get it done before Thanksgiving. So if you didn't notice on here, so next Thursday we're trying to quiz on this. It's not a test, so it won't be that bad, but it is a quiz next Thursday over all this stuff. No. So, got to be here. What's up? We'll see. So, all that ahead. So again, I know it might seem like a rough week because we're going to do something new every day. We're going to get this stuff in and get it done. That way you don't have to think about it after the break. So again, if you stay with me, I know we're doing a, more rigorous pace, but stay with me. So here's the point of a centroid, okay? This is what Mrs. Marrero was trying to get at with the mobile, okay? When you have a triangle, there's a point where it balances, okay? So I want everyone to underline right here. It is the center of gravity. Maybe a couple of underlines, so you know that's super important. I'm telling you right now, it will be on your quiz. Which center is the center of gravity? The centroid. Okay, so does everyone know this? Centroid, center of gravity. So let me show you what I mean. I did this earlier. Can you see the center of this? It's supposed to clear up. Okay, there it is. Okay, so does everyone see the center of this triangle? So what I did was I folded each side, found the midpoint, folded this side, found the midpoint, folded this side, found the midpoint, and then I connected the midpoint to the vertex. What do you call that again when you connect midpoint to vertex? Medians. So I found 3 medians, and I found a point of what? Point of concurrency. And this point of concurrency is called a centroid. So we just learned that the centroid is the center of gravity. So theoretically, I should be able to pick this up and balance it on my pencil. So let me see if I can do that. Here. All right, so let me back up here. Oh, check this out. All right. Will this balance on this pencil? Oh my gosh. Ooh. Yeah, I had to put a hole in it because I got a dull pencil. Yay. All right, so it works. It's magic. No, it's math. Mathemagical. So, but for realsies, you have to know centroid is where it balances. So, when you make three medians, that's where a triangle balances. Cool? All right. Now, back on track. When you have a centroid, when you have those three medians, does everyone see the centroid theorem here in the middle? Okay? You have to write it. It's already on there. Now, check it out. This is something you have to know. Listen. The centroid is 2/3 of the distance from each vertex. Okay, so look right here on this little diagram. AP, one second, from this centroid to this vertex is what fraction? 2/3. So put a little 2/3 here. 2/3. If I knew the whole segment from A to P would be just 2/3 of the whole median. That means P to Y is not 2/3, it's what's left over after 2/3. 1/3. Okay? So if you know the whole segment, then the bigger part is 2/3 and the smaller part is 1/3. Okay? That's the new thing for today. Everyone has agreed in the last two classes, when we do these practice problems, it can be difficult. So I really want you to pay very close attention. Okay? Because I don't have enough time to reteach this to everybody. So everyone's going to pay attention, right? Okay. Okay, down here, on number 1, check it out. AF equals 9. So, here's how this breaks down. There are 3 parts of this. There's the whole segment, there's the bigger section, and the smaller section, okay? So, when I'm looking at AF, A all the way to F, that's the whole thing. Let me make that nicer. You can label that real quick for me, okay? Try it one more time. There we go. From A to F is 9, all the way across. So, we just learned what? That from the centroid to the vertex, the long section is 2/3, okay? So let me tell you what we're going to write here, okay? If I know the whole thing, I'm going to multiply it times 2/3. So AF, the whole thing, right? So if I know the whole thing is 9, I multiply that by 2/3 to get the big segment, which is A to G. Okay, so again, I want you to know why I'm saying these words. AG is big, GF is small, AF is all the way. That's the whole thing. So check it out. The whole thing we just said is 9. So 9 times 2/3 is 18/3. But so if you don't know how to do it in your brain, you could use your calculator, but you should get what? 6. So if you were multiplying it 9 times 2 on top, divided by 3 on the bottom. So 18/3. Yeah. So again, that gave me the big segment, which is AG. So 6. Okay? So let me stop right here. Does anyone have a question on how I got 6? It's like, yeah, anytime you have the whole segment, right. If I had EC times 2/3 would give me GC, yeah. Okay, back it up. How did we get 2/3? We know if we have a centroid, from the center to the corner is 2/3. All the time. And that means from the center to the other midpoint is 1/3. We're going to get to that next. So, real quick, what if I'm looking for GF, though? So, what fraction is GF? The smaller one is 1/3, okay? So, real quick, whole times 1/3 equals the small. Yeah. So, 9 times 1/3 is 3. So, GF is 3. And guess what? It makes sense because 6 plus 3 is the total, which is 9. Okay? Now, a lot of people get this, and then on the next one, get lost. So stay with me. Okay? So, real quick, we said AF was 9. They're asking us to find AG. What is AG? Well, once we applied 2/3, we got what right here? 6. So AG equals 6. Okay, now, I'm going to do this in blue. Sometimes they don't give you the whole thing. Sometimes they give you one of the little parts. Right, so let me show you. GE is 2.4. So I'm going to label GE right here is 2.4. Now, one second, is GE the small part or the big part? The small part, right? Now, right here, yeah. So here's the deal. If this is 2.4, we're looking for GC and then the whole thing, right? Now, real quick. You can do it that way. But real quick, let me explain something. Tell me the relationship between 1/3 and 2/3. Right, they add up to a whole, but do y'all agree that 2/3 is twice as big as 1/3? Because there's 2 1/3s and 2/3, right? So look at the red numbers, 3 and 6, right? Do you see how I just doubled? So here's the rule. If you have the small piece, okay, the small one, hold on, times 2 will give you the big one. Okay, good. So small one times 2 gives you the big one, and the small one times 3 will give you the whole thing. But real quick, let's find the big one. So the small part is 2.4. Check it out. 2.4 times 2 is what? So my big part, which is G to C, this is 4.8. Now, but hold on, I'm not looking for GC, I'm looking for CE, which is, hold on, CE is all the way across. So if I have each part, what do I do with those two numbers? Add them up. So 2.4 and 4.8, add them up. 2.4 plus 4.8 gives me 7.2. So EC, or CE, sorry, is 7.2. So in blue up here, this is the one where people get stuck. So again, anytime you're given the small one, or even the big one, you're not using 1/3 and 2/3 anymore. Okay, you're kind of thinking, well, the relationship is half. Yeah, because number 1 had 2 questions. Find AG and CE. We're about to do number 2, though. Right. Right. It's not really a midpoint. Yeah. Right. If you had 6, you could have just divided it by 2 to get, yeah, the 3. Right. 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 Yeah, if you know the big part, divide it by 2 to get the small part. So I'll put that here. Big divided by 2 equals small. That's another thing we know. Okay, now, let's try another example together. Do this green. It says ZW is 7. Okay, again, this is brand new stuff. Is everyone paying attention? No phones? ZW is 7. So from here to here, right? So 7. Is that the small part, the big part, or the whole thing? So ZW is smaller than ZK, right? So we just did this in blue. If ZW is the small part, small times 2 gives me big, right? Right, so check it out. Let me write that down. Small times 2 equals big. So 7 times 2 equals 14. So Z to K is 14. But what am I looking for? I'm looking for KW. KW is all the way. So what do I do with these two? Add them up. So 7 plus 14 is 21. So that's KW, yeah, equals 21. All right, last one. LX is 8.1. LX is that a part or is that the whole thing? LX goes all the way across, right? Look where L and X are. They're all the way. So now this goes back to the red stuff. If you know the whole dang thing, you're going to multiply by 2/3 and 1/3 to get each part. This red one. If you know the whole thing, times it by 2/3 to get the big part, times it by 1/3 to get the small part. Okay, let me show you. Whole times 2/3 equals the big. So the whole thing is what again? No. It tells us right here. LX is 8.1, right? So 8.1 times 2/3. What's 8.1 times 2/3? 5.4. That's my big part. So the big one is L. There we go, 5.4. Is that what I'm looking for? I'm looking for LZ, Jay-Z's lost cousin. Thank you. All right, but LZ is 5.4 because it's the big part, 2/3 of the whole. So LZ is 5.4. And to get the smaller part, you don't need to, but yeah, to get it, you could just divide 5.4 by 2. Yeah. Yes. No. We're almost done, though. I just want you to be here for the last one. Yes. 2.7. 2.7. All right, flip it over, please. And we're gonna skip example 3. Lucky y'all, because that one's kind of tough. Yeah, don't worry about this number 3. Skip it. But last one, this one should be not too bad because it's like the warm-up. Did everyone skip number 3? Everybody. Okay, number 4. It says the diagram shows the plan for a triangular piece of a mobile. Where should the sculptor attach the supports that the triangle is balanced? Balanced means, and I hope you never forget this image where you see Mr. G at the front balancing a triangle on a pencil, right? So, what do you call the point that balances it? Centroid. Centroid. Okay? So even though it doesn't use the word centroid, you need to know that you need to make 3 medians and find the centroid. Okay? So balance means centroid. Centroid means 3 medians. So can everyone make 3 medians? Well, to get medians, I need 3 midpoints. Halfway. Hold on. So, check it out. Here's how I would find the midpoint of QR. Left to right, how many units does QR go? How many units is this from left to right? 6. So half of 6 is 3. So 1, 2, 3. I go straight down, put a point there. That's my midpoint. So again, find the midpoint of each segment. So from Q to P, how many units left and right is this right here? 3. Half of 3 is 1 1/2. And go straight up, put a point. And the same thing for PR. How many units left and right? Half of 3 is 1 1/2. Go straight up, put a point. Now, can you make straight lines using your protractor from vertex to midpoint? So here's a median right here. Here's a median right here. Here's a median right here. Do you see the point of concurrency where they all cross? Okay, centroid is that point of concurrency. That's where it will balance. And who can tell me what is the coordinates? What are the coordinates of that point? So 3, 4. 3, 4. That's the answer. I need that coordinate of that centroid. Okay?
That's all? That's all, sir?
Okay. That's it for that one. Yeah.
You did all that?
Now, I wrote a lot of stuff because we're doing notes. So, now I don't want you to freak out. So, y'all ready to not freak out? Don't freak out. So, check it out. So, here's the deal. I'm giving you all the assignments for the week at once. So, this is not just for today. I had someone in first period freak out because they don't listen. And they're like, what? We got to do this today? Even though I literally said you don't have to do it all today. So, anyways. No, I bet you can't. So, here's the deal. Each day we'll do something new. You do a one-sided assignment, okay? So it's not as bad as it looks. Yeah, so what you're going to do today is the first page, front side. Tomorrow is the second page, and then keep going, right? So don't lose this. If you lose it, you lose all the work you did, and you are not allowed to, quote-unquote, get it from your friend, because it is an assignment, not notes, okay? So I'm going to pass this out. Right, due next week. What? This is the assignment. Did you just say this is the assignment for today? Oh my gosh. Oh, okay. So far, so good. Here, let me take one. Put it over here. All right, so everyone knows what they're doing. Let's get started.